The skies light up due to the G4 geomagnetic storm, a rare but striking phenomenon. Such a spectacle, awe-inspiring and ominous, raises the question, what would cause such a phenomenon? Originating from the sun, this colossal disturbance, spurred by massive bursts of solar energy and magnetic fields, is not just a visual marvel but a powerful cosmic occurrence. These storms, though infrequent, underscore the sun's formidable influence on Earth. This isn't science fiction. It's a real cosmic event unfolding above us. The sun is currently exhibiting a tantrum of epic proportions. Sunspots, the dark patches that occasionally mar the sun's blazing facade, are the birthplaces of solar flares and the architects of geomagnetic storms. These spots are cooler areas on the sun's surface, where intense magnetic activity disrupts the normal flow of solar energies. The particular sunspot responsible for the imminent G4 storm is colossal, almost 200,000 miles long and dwarfing Earth many times over. Imagine a giant whirlpool of magnetic fields, twisting and turning, where energy builds up over time. This energy, stored in the tangled magnetic fields, eventually reaches a tipping point and is released in the form of solar flares and coronal mass ejections. These explosive events hurl massive quantities of charged particles into space, some of which are directed at our planet. The sunspot in question, a giant darker area on the sun's surface, is not just a spot but a powerhouse of magnetic turmoil. When the sun sneezes, Earth catches a cold. But how does this solar sneeze affect our planet? In 2024, scientists recorded an unprecedented number of solar flares and geomagnetic storms, tallying over 150 significant events. Geomagnetic storms are a fascinating yet disruptive force of nature, originating from the sun. At the heart of these storms lies the solar wind, a stream of charged particles that, when hurled towards Earth, can interact violently with our planet's magnetic field. This interaction distorts and compresses the magnetic field and can induce electric currents in the Earth's surface. A particularly intense form of these storms is classified as a G4 category storm. This classification is part of a scale where G1 is minor and G5 is extreme. A G4 storm, also known as a severe storm, can unleash dramatic consequences on Earth's technological infrastructure. For instance, satellite operations can face significant disruptions, which affects GPS navigation, mobile phone signals, and satellite TV. Additionally, power grids can experience voltage fluctuations leading to widespread power outages. Moreover, these storms can impact radio communications by disturbing the ionosphere, a layer of Earth's atmosphere that radio waves bounce off to travel long distances. During a G4 storm, this layer becomes so agitated that it can block high-frequency radio waves, disrupting communication and navigation systems reliant on these frequencies. The dance between the solar wind and Earth's magnetosphere is not just a scientific curiosity. It holds implications for our daily lives and the functioning of numerous technological systems. A G4 storm is like a giant wave crashing into the calm seas of our magnetic field, with effects that ripple through our atmosphere and technologies. As this storm barrels towards us, what signs should we watch for, and how might our world change, even if temporarily? When a G4 geomagnetic storm graces our skies, it brings with it a spectacular display of auroras, stretching far beyond their usual polar realms. Imagine the northern lights dancing above the Golden Gate Bridge, or the southern lights shimmering over the Sydney Opera House. These celestial phenomena, while breathtaking, signal that there is a lot going on in our atmosphere that we need to pay attention to. But the beauty of these lights masks deeper disruptions. GPS signals could get scrambled, and power grids might experience unexpected stress. Airlines, ever cautious, reroute flights to avoid high radiation zones, while astronauts in space hunker down in shielded modules of the International Space Station. On the ground, agencies and companies brace themselves. They upgrade software, shield critical components, and prepare contingency plans. Everyone from government officials to individual tech users is advised to back up data and stay informed through reliable sources. While the northern and southern lights dazzle, beneath them lies a web of vulnerable human technology. As we experience this cosmic event, what should we take away from this encounter? The sunspot responsible for this uproar is vast enough to swallow multiple Earths, has unleashed forces that ripple through space, impacting our planet. This particular storm, classified as a G4, is a phenomenon powerful enough to disrupt satellites, affect electrical grids, and dazzle the skies with vivid auroras. Understanding these geomagnetic storms is important. The effects range from the beautiful to the burdensome, showcasing the dual nature of solar activities. Preparedness and research are our best tools. By advancing our knowledge and technology, we aim to mitigate the effects of these solar outbursts. Every storm gives us insight into the sun's mechanics and helps us refine our predictions and defenses. With each storm, the universe whispers secrets of its immense power and complexity, urging us to listen, learn, and prepare.